Yes, so hello friends, this is the video tutorial for Biweekly Contest 167 of Leetcode, which is still going on. I was able to solve all the four problems, so we'll discuss that. I think the contest was the first few problems were quite easy. Yeah, I like my ranking is very less because of the WAs, the wrong answers that I submitted, a lot of them. So yeah, we'll try to improve on that. Let's begin with the first problem and discuss them. I think it's a pretty simple problem. I also messed up in this. So what I messed up is this, that the encoding. So what the question basically says is you have to encode a string. Let's say your string is A, B, C, D. So A gets marked to 1, B gets marked to 2, C gets marked to 3. Right? Makes sense? C gets marked to 3. I missed this encoding to A, 0, and B. So that's why I got my first WA. But enough about me. D gets marked to 4. So what you need to do is find a point such that the left sum is equals to right sum. So left sum equals to right sum. We can do this quite easily. You can even brute force this because I saw that the constraint is very less. Yeah, constraint n is 100. Don't mind my voice. I'm a bit sick. That's fine. So you can brute force this, but what you can also do is just get the total sum. So total sum here is basically 1 plus 2 plus 3 plus 4. So that is 1 plus 2 plus 3 plus 4. That is 7, 10. I'm skipping over the first couple of problems because I think they are quite easy and intuitive. I don't think we need to discuss them a lot. So that's why I'm moving fast. Okay, so you get the total sum and you find the first point where 2 times left sum is equals to total sum. Why does this matter? Because see, if left sum equals to right sum, and I also know that ls plus rs equals to ts, so I can do this is substitute rs with ls, so I get 2rs equals to ts, right? So I just need this point, and if this point exists, then return true, then true, else you can just return false. I should probably write straight up, else return false. So hopefully this makes sense. So what? Let's go over the code. What I did, I actually created this prefix sum array, but I don't think you need this. So you can just do is create a ts here. Ts equals to 0, and do just a ts plus equals to si minus a plus 1. Right? I'm not going to submit this because I think it will then count my last summation. That won't be very, and will drop my rating, I think. So yeah, all you need to do is get this ts and find the first point where the sum, or basically ls, are left sum. So left sum, 2 times left sum equals to 2s. If such a point exists, return true, else return false. Hopefully makes sense. We can now jump over to the next problem. Question number 2. This is, I think, a bit better problem, but I think I've solved a lot of problems like this, so I got to the solution quite easily. Okay, yeah. So what this problem says is you're given a positive integer array nums. Okay, nums of Fibonacci array is a continuous sequence. So I think we all know what Fibonacci array is. Like the most common Fibonacci is this 1, 1, 2, 3, 5. But again, there could be other Fibonacci's as well. What Fibonacci depends upon is the starting 2 points. So this depends on x and y. Why? Because let's say I have this x and y points, right? So these are my two starting points. Next would be x plus y. Next would be x plus 2y. Next would be 2x plus 3y. Next would be 3x plus 5y. So this kind of thing, right? 3x plus 5y. So this is also Fibonacci. So all, like, my whole Fibonacci array will just depend on the first two values. So if I know the first two values, I know the rest of the array as well, or I can determine it. Okay, so enough about this. Let's go over what the question asks. Fibonacci array is a continuous sequence whose third and subsequent elements each equal to the sum of the two preceding terms. Return the length of the longest Fibonacci subarray in nums. Subarray of length 1 or 2 are always Fibonacci. So this is an important point here. A subarray is a continuous I think we all know what a subarray is. Okay, so how do you solve this thing? The first thing that should come up to your mind is this: like, if you have solved Fibonacci a couple of times, or Fibonacci related problems, is this like, if you know the first two problems, you actually know the first points, you actually know the whole array. But I don't think that, like, that conclusion is very important or very useful here. So what you need actually is seeing that, okay, if Yeah. So what you need is, how do I explain this? Okay. If let's say there's an array that is Fibonacci. So let's say starting point is 3, 5, 8, 8, and the next point would be 13 and 21. Okay. So if there's this Fibonacci array, this is whole of Fibonacci array. Can I say for what terms the like actual like the preceding to sum equals to, like what is the condition of the Fibonacci? AI equals to AI minus 1 plus AI minus 2, like the previous two terms, right? So for what values this condition is actually met, or for these two values, right? Can I say that if the condition is met for some values and the next condition is also met, like this, like the next value here is 21 plus 13, that is 34, I think. Yeah. So can I say that, okay, if I know that, uh, so if the condition is getting met, I can should keep going, right? And I want the maximum error. So I should find the point, first point, first point where condition is not met, is not met. Let's say this point where the condition is not met is J, and like the way from where our array started to meet the condition is I. So the condition is basically this. What I'm referring by condition is. What would be the length of my like the Fibonacci subarray? It would be j minus I. Okay, so j minus I is this part for which the condition is met, plus the starting two values, right? Because the starting two values don't need to meet the condition. So this would be the answer. And now if we have proceeded this, where should we next start condition? Or we should next start checking, because we should do I equals to this. So this comes down to a 2 point problem, right? So for like the ith point, what I'm saying is, for I, find j where condition not met, and this would be your current answer. This would be your Fibonacci length adder, and then move I to j, and then continue this process and return the maximum of this. Hopefully this makes sense. Like we can, yeah, this is pretty easy. Let's jump to the code. So what I actually did, I created a check array. I don't think this check array is actually needed, when because I was coding very fast. I just say, okay, let's create this array. I don't think this check array is needed, because in the this 2 pointer only, you can actually yeah, you can actually do this check. You don't need to pre-compute this. But what this check array is doing is just computing that if is the condition getting met for this I index. So I started from I equals to 2 for, because for the first two index, the check the condition, that is the array values equal to the preceding two values sum, cannot be true. Like there are no two preceding values. Okay. So if this condition is met, I check I equals to true, else it will remain false. So in this 2 pointer like progression of the array, what I did is the condition is not getting met at this point. You cannot start from this point, so that we just continued I plus plus, and then I found the first point where this condition is not getting met. So check j. You can do this is, rather than doing this, is do something like nums j is not equals to nums j minus 1 plus nums j minus 2. What this would do is, not, you don't need to actually create this check array, but let's keep the code as it is. So, and checks day. So while this is true, you do j plus plus. I said, like I said, see, current answer would be j minus I plus 2, and you do in the answer variable store the maximum current answer, and you move your I to j. Hopefully this makes sense. Let's jump to the next question. Next question is also, I think, a pretty easy and pretty like straightforward, and I would also say a pretty patterned problem. Just give me one second. Yeah. It's a style problem. I think some people struggle with design style problems. I really like them. I think they are quite in, like you can draw conclusions and draw your own data structures. I like those problems, and I think I'm pretty decent at them. So let's see what this design style problem says. Okay, sorry. Alice frequently takes exam and wants to track her. Okay, why did that happen? Track her scores and calculate the total score over the specific time periods. Implement the exam tracker class. Exam tracker, this is just your constructor. So void record. So what this says is Alice took an exam at time this and got a score of this, then okay, so that's fine. Then what the actual query is here is that you are given a start time, you are given an end time. What are all the sum of okay, scroll this here, sum of exams taken in the less than end, and so this interval, what are all the exams taken and the score, the sum of the scores in she got in those tests, and total sum of all the exams taken by Alice between this and this time inclusive. If there are no recorded exam taken by Alice within the specific time period, returns zero. It is guaranteed that the function calls are made in. So this makes this question very easy. Are made in chronological order. So that is that whatever your TI would be is greater than equal to it. Even says is greater than equal to TI minus. So it would be making strictly time increasing order. Alice never, and this is like fine. Okay. So how do you solve this? Okay. What do we need? Actually, if let's say we have the score array, right? If we have this score array, right? And is this not just, let's say I have this score array of she took some test, got 2, then she got 5, then she got 5, then she got 7, then she got 8, then she got 10. Okay. And if I didn't know, like, yes, the query is on time, but let's say if it was on the index of the score. So if I had to know the sum of the scores between 0, 1, 2, 3, 4, 5. So between 1 and 3, what you would do is, okay, one way is doing this, but obviously we know we can use a prefix sum here. Right? You would create a prefix sum array. That would be 2, 7, 12, 19, 27, 37, and then you would just do PS of 3 minus PS of 0 and get the answer of 19 minus 2, that is 17, and that's 2, right? 5 plus 5 plus 7. Okay, so one thing is true that okay, if I know the score array, right? I don't know the score array. Okay, what happened here? I don't know the score array exactly, but I'm given a stream of score, right? Stream of score. So from the stream I can create this prefix sum. And how would this prefix sum be useful to me is, let's say a stream of score I reduce to prefix sum, and I think that's pretty easy to do. Whenever you get a score, so yeah, this operation, what is this called? Yeah, record. So whenever you get record time comma score, what you need to do is ps dot pushback ps dot back plus score, right? Plus score. And that's how this ps get maintained. That's fine, and that's useful to us because we see that any indexing kind of query on the score we can solve using prefix sum. But how do you convert your start time and your end time into indexing on score? Because if you can do this, this becomes that this question is solved. So how you can do this? Think about this. What is the key? Like what makes this question very easy? Calls to record are made in chronological order. I think if it weren't even made in chronological order, I think even that could be solved. But yeah, that would have been a bit more interesting. So because I know that my t is in increasing order, I can also maintain a times array and just push back this current time. And then when I get a query, so when I get a query for start and end, see, at each record I'm pushing one element into my prefix sum, I am pushing one element into my times array. So these two would have same array, same like length. And also when I am maintaining this ps, I'm also maintaining this ts. What is this ts? This ts is an increasing array, and this is basically that for this score, what is the time that I need. So why do you need both of them? Like, yes, it is easy to understand when I'm telling that, okay, you create this data structure, you create this data structure, but you should also be able to think why I need that, like this times array. So you need this times array because you want to convert your like the query on the time to query on the index. And if you know the time for each of them, like let's say this was at time 1, this was at time 3, this was at time 10, this was at 15, 20, 100, right? If you knew this times can, and you know then you also know that your start is something like a 7 and end is something like a 25. So then can you not use your lower bound upper bound functions on this and get the first, like get the range for which these the values are between this? That's why you need this times R. So yeah, so like for this 7, the first index would be 2, that is inside this range 7 to 25, and the last index would be 2, 3, and 4. Yes. So yeah, in query, you will find the first point that's inside this array, call this as, find the last point that is inside this array E, and then return the prefix sum E minus PS S minus 1. Hopefully this makes sense. Okay, where's the window go? There it is. Alright. So yeah, let's jump into the code. So yeah, I just created this stamps array and this prefix sum array, and I didn't do anything in the constructor. In the record function, as I said, I just pushed back the time and created. So I got the WA because of this, because what I did is added this PS dot backend directly into score, and this would obviously overflow because see the scores are 10 is to the power 9, and the number of queries may are 10 raised to the 5, so it could go, the prefix sum could go as long as 10 raised to the 14. So that's why I got one WA in this. Bad luck for me. Got two WAs for no reason. In D problem, I deserve WAs. Like I didn't even know the logic. So we'll go through D after this, but yeah. So I just stored the score into a long because, as I said, this could overflow. Then I pushed this back into the prefix sum with the last element, and so yeah, what we do in this total score query is using lower bound. I find the first point. So in the first point, that is greater than equals to start time, and then our start would be this. So what I mean here is, like if I know an event's timestamps like 1, 5, 7, 10, 14, and I want the first point that is like rather than this, let's say I want the number of points that are between the index that have the value in between 3 to 11. How will you do this? You'll find the first point that is greater than 3, that is 5. So this is what my lower bound will do. It will give me the first point that's greater than 3, and I also know need my first point that is less than this. So I will get an upper bound for this, so that would be 14, and then move the upper bound back one index because that would be less than or equal to your 11. So yeah, I got the first starting index using lower bound, and I got the upper bound using uh, and I got the last point at the ending index using upper bound. The one thing to notice, my sum here is not inclusive, so it's actually doing s to e minus 1. So that's why I do this trick, that if e equals to 0, if e is double zero, just return 0. Yeah, and yeah, it's pretty simple. You just get the prefix sum from s to e minus 1. Yeah, hopefully this makes sense. Let's go move to the problem that I think most of you are here to watch the solution for. That is the last problem. I think this is a good problem, and even like, so I made like 2 or 3 wrong answers because I didn't got to the logic of how to even solve this. When I did, it was nice. Why is this coming so small? Score at, why is this happening? Okay, just give me 1 second. Command shift. Okay, it's control command shift 4. What is it? Okay, I think now it should work. Yeah. Okay. Maximum partition factors. One thing that I think this problem was not written in a good way. I think it's very confusing to understand. Like the first wrong answer went because I didn't even understand the problem correctly. Okay, but fine. You're given a 2D integer array points, where points is just a point on Cartesian plane. Okay. Represent points on so xy points. The Manhattan distance between these 2 points are this. So I think we should know what the Manhattan distance is. It's just the absolute. Okay. So absolute of x2 minus x1 plus absolute of y2 minus y1. I don't think this question like even needs Manhattan distance if it was like the normal distance of under root distance. I don't know what it's called. Is it called Cartesian distance? You can, the solution would remain same. Okay, split the endpoints into exactly two non-empty. This is important. Non-empty groups. The partition factor of a split is the minimum Manhattan distance among all the unordered pairs of points that lie on the same group. Return the maximum possible partition factor. Okay, so yeah, one thing it written here is that when n equals to 2, you have no choice. You need 1 point here, 1 point here, and for 1 point, there are no grouping between. So there are no distances between the groups here and the groups here, right? So what this problem actually means, let's explain this because I think a lot of people might not understand it in the first go. So what it means is you have some endpoints. You have to break them down into some k and then n minus k, where obviously the both of them cannot be empty. So you break these points down into these two things, right? So some k points go in. Okay, sorry. So some k points go in group one, and some n minus k points go in group two. Now, for these group k group one, you find for all pairs minimum distance for all pairs minimum distance. Now, the minimum of these two values is actually the partition factor. Minimum is partition factor. So this is what the partition factor is, and then you are asked to maximize this. Maximize this. Okay, so now I think people should be able to understand. So yeah, it's confusing. Like in my first go, I was like, okay, you are taking the decision between group one or group two. What? How are we distributing the point? Like, is a point from group one able to like have a distance with group two? No. So group one's distance would be with each other's point. Group two's distance would be with each other's point. Okay, how do you solve this? So yeah, you can like think about this. A lot of things can come up to, but until you understand this is a binary search question, you can't be able to solve it. And how you will think this is a binary search question is just a fact. This, you are asked to find maximum. Whenever you are asked to find minimum or maximum, at least you should think for 1 minute or 30 seconds. Can I use binary search in this problem? And why can I use binary search in this problem? If let's say this is a maximum partition factor. Maximum partition factors. So what this means is I was given some points. Let's say points are like this. Hmm. So I was able to break. I was able to break these points now into some group one and some group two, such that the for let's say maximum track is like let's say 10. So all points here have in between themselves have a this is less than 10, and here also less than 10. Less than 10. Okay. So can I say that can I get a bigger partition factor? Or rather, sorry, all points have a greater than equals to 10. Here also have a distance of greater than equals to 10. So can I say that, can I get a lesser maximum partition factor like 8? Yes, I can use the same break, like the same way I broke my points. And if every distance is greater than 10, it will always also be greater than 8. Yes. So that's why that. So that's how we can use binary search, because see, when does binary search work? Or binary search on answer, basically on answer. When if x is valid, x minus 1 should also be valid. Valid here meaning that it can be the answer, right? Okay. So even if you came up with the point, okay, I need binary search on answer here, I don't think it's still very easy to come up with the rest of the logic. So how do you come up with the rest of the logic? So now how, what my points, what my reduced to, what my question reduced to. Uh, So why binary search is useful here? We can see that our question was in the form of what was the function name. The function name is max partition factor. Okay, so you are given some points, max partition factor for some points, right? Now I know that I should use binary search here. So now my question reduces to, I will do some, I think we all know how binary search on answer works, but yeah. So you will do some while L is less than equals to R, you find the mid equals to L plus R by 2. And now you will check if valid points M. So now if I can get the code for this valid function, I think I should be able to solve the rest of the problem, because what this problem then reduces to, if it is valid, you will check a bigger value. Else you know that, okay, if this point is not valid, all future valid points will also be not valid. So else you will do R equals to M minus 1, yeah, and just return the R. Fine. Because you want the maximum value, right? Okay. So now my question reduces to this: getting this valid function. What this valid function should do is take some points, valid function, so points, and then take a distance, so maximum distance. This should check, is it possible? Is it possible to distribute these points into two sets, two non-empty sets, such that my max distance condition is not violated? So that the distance between all of them, or this should be actually minimum distance. Alright. So the minimum distance between the points in group 1 and points in group 2 is greater than equals to minimum distance. Okay. How do you do this? The points are in 2D. Whenever you see something in 2D, you should first see if I can solve this in 1D, and then get the conclusion that you solve this using in that how you solve this in 1D, and then try to implement this in 2D. This is how you should think about it, because 2D is complex, 1D is simpler. So let's, what is 1D? 1D is just a number line. Let's see. I have some number lines. I have a number line. This is my number line. And let's say I have these points. So one point is here, one point is at 5, one point is at 7, one point is at 9. Okay, I am wonky. Why is, okay. So, shit. So 7 should come, 9 should come here. And let's say I have 30. Now let's say I have D of, so the minimum distance, basically, minimum distance. The for the like breaking, the minimum distance allowed is 3. Okay, how do you solve this? I know that each point has to go in one set. Let's say I put one in one set, right? Set one. Now one in one set. What about set two? For what about 5? So set one has one. Set two has. Let's say set. What about 5? Can I put 5 in set one? Yeah, you. I can put set in 5 one. Set in 5, because see, 5 minus 1 is 4. 4 is greater than 3. That's no problem. Can I put in set 2? Set 2 has no values. I can put it in in anywhere. So yeah, that's why this question becomes complex. Because if you try putting this, then if every point would have two choices, and then every point would have two choices, and then it would go to, like, if you have n points, 2 raised to power n solution. That is not what you need, because let's say first you try putting it here, then you go to the next point, check for it, where should I put this, and uh, then you trigger back, or basically backtrack, and then try to put in the other set. And yeah, that is very time consuming and not optimized at all. You can think about DP solution. I was not able to get like any DP thing. I don't think this can be solved using DP. What this can be solved is that, okay, I know that one is not violating any condition. Like I can put one anywhere. Okay, 5 I can put anywhere. But what about 5 and 7? What is the conclusion on 5 and 7? Can 5 and 7 be in the same set? No, they cannot be. What's the distance between 5 and 7? So 5 and 7 has a distance of 2. What is my minimum distance? My minimum distance allowed is 3. So if 5 is in set 1, 7 has to be in set 2. Okay, okay. I know a graph problem that I can use here. So what this question actually reduces to is two colorable. Is my graph two colorable? Why two colorable? Because I have only two sets to choose from. So what I mean by this is, what would be on my graph here? Let's say I have one, like one point here. So does one have any problem with anyone? No, it hasn't. Like you can put one with any value, it doesn't have any problem. Its distance would always be greater than the minimum distance. So the one will remain as it is. Now what about 5? 5 has problems. 5 has problem with 7. because see 5 and 7 cannot be in the same set, so that's why I draw an edge here. Now what about 7? 7 also has a problem with 9. 7 has a problem with 9. The 9 doesn't have any problem with 13. That's fine. So can I say that this graph is too colorable? Yes, I can say that this graph is too colorable. I can color this 0, this as 1, and this as 0. So what this question then reduces to, okay, I can break this down as 1, 5, 9, 13, and 7 here. Because see, every point here has a distance greater than 2, every point here has a distance greater than 7. The question is done. If you can get to this point, the question is actually done, because all you need to check is get the points that are in violation, and get and check if your graph is two colored. That's it. And see, this I discussed this in 1D, but how would this change it 2D? It wouldn't change. Only the algorithm to calculate the distance would change. Like the same logic applies for 2D. So that's why I said whenever you see something in 2D or 3D, try to reduce the dimension and see get any conclusion, and then try to use that conclusion in the solution. Let's jump to the code. So as I said, this we can use a binary search. Okay, I'm done with the contest, bro. So as I said, we can do a binary search. So one thing you need to explicitly handle, I think, even without explicitly handle, it might work, but it's better to explicitly handle it. If you have 2 points, you have no choice. You just need to distribute 1 point in this set, 1 point in this set. There are no. I think if in this condition, our code would return max int max, but the answer they want is 0, because they said so. Define the partition factors n equals to 0. Yeah, explicitly handle it, then use a binary search. As I said, we'll create a valid check here. For this valid, we'll just check if these points can be distributed with the minimum distance of m. So how we do this is create this valid function. I get all the points, I create this adjacency, and this we can. Okay, so one thing I should have told you is the constraint. I'm so sorry. So why this solution even works, or why you can think about using binary search, or and all of this is because n is 500. N is 500, and it's 500 rather. So n cube, I think, can work very like can, and it cannot. It's in both states, but something like an n square is what's n square here is 25 into 10 raised to the power 5. So that is very less, 2.5 into 10 to the power 5. Right? You can add some factor here. So that the factor is log n here. Log n for the binary search. So that's why. So the total time complexity is log n square, and that is very much fine for these constraints. I should have said this in the starting of the problem discussion, but so, my bad. So what I did is just see this is log n, and this is the major part here, that is log n square. So I get the distance between all the points, and so get the points that have violation. So violation meaning they have the distance less than minimum distance. So if the distance is less than minimum distance, I add this to my adjacency, because see these two cannot be together. So that's why we do like here, as we said, 5 and 7 should be connected to each other, and these two cannot have the same color, or they cannot be in the same set. So and then you just need to do a two colorable check on this adjacency. What this two colorable check, I think you can be able to, like, you can implement this anyways. So how I implemented this is just created this colors vector. If and initially I color because see the graph may not be connected, right, as we saw here. One is not connected to anything, one has no problem with itself. So if a point so that's why we need a visited array here as well. And I like see visited and color, you can combine this into one color array as well, and then implement this thing -1 0 1. So -1 being it's not visited, 0 is that it has color 0, color 0, and 1 is that it has color 1. So that's how I combined both of them. So initially everything is not visited, so that's why all the values are -1. Now you just go over all the points and see if it is already visited. You don't need to do anything, like just a BFS traversal. This is just, and then you push this into the color. Use a queue here. I use a BFS. You can use DFS, and you just need to check if this component is two colorable. How you can do this is initialize the first value with a color of 0, go over all the next point and see if the if you are at 0, the next if so basically what I do is, like, if I'm doing a BFS shower cell here, I'm at this point u, and these are all the adjacency points things, see. So if uh, 0, and if let's say there's a color, there's an edge to a point that has a color of -1, I should assign this color 1. If there's something that has a color 1, that's fine. 0 and 1 do not match. If there's a edge that has same color 0 and 0, then I should return my false, because see, someone said that you should have 0 color, I also have 0 color, and I have an edge with you, so both of them cannot be in the same set, so this graph is not too colorable. Yeah, that's why what we do here is, else if color are same and there's an edge between them, return false. Else you can just make this make sense, right? Yeah. So yeah, this was a good contest. Hopefully you were able to grasp something. I think D is a very good problem, and like you should try to solve it. Even though after understanding the problem, you should still try to implement this. Yeah. That's it from my end. Thank you for watching. Bye bye.